Hello, class. First thing I want to do is for anyone who needs to see the problems from the textbook, I want to show those to you. So we're on page 381 in the textbook for number 15. Here are the instructions. And it says find sine, cosine, tangent, but I gave instructions just to find sine. So you're going to find the sine of 195 using the fact that 195 can be written as 225 minus 30. And then number 17, you're only doing tangent. So for 17, find the tangent of this angle. The next problem you will do is number 29. And for number 29, here it is. So 29 is this one. You're writing the expression as sine, cosine, or tangent of an angle. And number 31 is here. Number 66. On the next page, here's number 66. 66 is verify the identity. And number 79 is next. The instructions are up above. Here's 79. And then on page 397, we have number 87. So the instructions down here are to solve. So we're finding the solutions from 0 to 2 pi for this equation. And then there's one more that is listed as a challenge for after you're finished everything else today if you wanted to try it. And that's on page 382, number 67. Okay, and this is a verify problem. So we're going to verify this algebraically, number 67, if you choose to do that challenge problem later. And if you can't find your textbook, you want to try to locate that soon, because eventually you will have to hand it in. I'm not sure when, over the summer or the fall, they haven't decided yet, but eventually you'll have to. Okay, so here come the answers. Answers to number 15. Here's number 17. $29 and $31. All those odds are in the back of the book anyway. But 66 isn't because it's even and it's a verify. So your work probably matches mine. 79's odd, so the answer is in the back of the book. But that is a false. 87, here are the answers. And now for anyone who would like to go through and take a little bit of a closer look at any of these problems, I'm going to do that now. So for number 15, we're finding sine. We're asked to use 225 minus 30. When you expand this, the sine formula says sine of u minus v equals sine of u cosine of v minus sine of v cosine of u. Or you can do cos u sine v. You can swap those if you prefer. When you go to find the sine of 225, you have to remember that 225 is in quadrant 3. So both sine and cosine are going to be negative. For 30 degrees, that's quadrant 1. So you don't have to worry about it because sine and cosine will be positive. You don't have to worry about the SIGNs. Number 17, you're asked to use pi over 4 minus 7 pi over 6. So here's the expansion. You want to make sure in your expansion that you have a minus here and a plus here from the formula. The tangent of 7 pi over 6, since 7 pi over 6 is quadrant 3, tangent is going to be positive. So since tangent of 30 is radical 3 over 3, tangent of 7 pi over 6 is also radical 3 over 3. So tangent of pi over 4 is the tangent of 45. That's 1. And then you have the rest filled in. This is where you should be at that intermediate step. This does not reduce to 1. It does not reduce to negative 1. What you want to do is you want to get the complex fraction out of there. So you want to get rid of the fraction or fraction, and you need to move the radical out of the denominator. You can technically take this one and at this step rationalize the denominator. But those of you who have tried that, I think you would agree it's much, much worse. Because to rationalize the denominator at this step, you'd have to multiply top and bottom by 1 minus radical 3 over 3. So picture foiling with that. It's not very pleasant. So that's why I strongly encourage you to clear the complex fraction first instead. So to clear the complex fraction, we'll multiply by 3 over 3. Sometimes people have a 1 here. They forget to distribute the 3. Make sure your signs, SIGNs, are still correct. And then to rationalize the denominator, you're going to multiply top and bottom by the conjugate of the denominator. And then carefully FOIL. So this is the next place to check to make sure that you don't have any sign errors while foiling or anything like that. A lot of times people will put a 9 here, sometimes a 6 by accident because they add instead of multiply. And then you can reduce, and you'll end up with 2 minus radical 3. Another way to reduce this, by the way, if you don't like the pull apart that I've been doing, is you can factor out a 6 from the top, and then 6 over 6 reduces, and you get 2 minus radical 3. So if you like that, you can do that instead. And if you are able to jump over here and reduce without showing an extra step of work, that's totally fine too. So it's okay to show this step. It's okay to show this step. It's okay to jump straight to that answer from here. Okay, for 29, what we were looking at in the book, it had tangent. It had the tangent formula expanded. So this is that going backwards one step problem. So I recognized that it was the tangent formula because there were lots of tangents all over the place. And then I noticed that in the top there was a minus and in the bottom there was a plus. So that leads me to, it's the tangent angle difference formula. So it's the tan u minus v formula. And using the two angles that we had, 325 minus 116 gives you 209. Make sure you have degrees in that answer. If you're missing degrees in the work, that's okay, but make sure you put degrees in the answer. And then for number 31, that's another one of those going backwards kind of one-step problems. This becomes 2 steps because you need a common denominator, but see how it's cos, cos, minus sine, sine? That at this point hopefully makes you think of cosine. And then since it's a minus in between, cosine's the annoying one where the SIGNs are opposite. So it's the cosine u plus v formula. So we need to add pi over 9 and pi over 7. For a common denominator, we'll multiply by 7 over 7 and 9 over 9. And that brings us to here. Number 66 is actually pretty quick. This is a verify problem. That means you want to make the two sides match. So if you expand, because you want to train yourself, whenever you see sine, cosine, tangent of a sum or a difference, you want to expand. So this is cos, cos minus sine, sine. And this is cos, cos plus sine, sine. And do make sure when it's cosine, see the one that has a sum of 2 angles, it gets the minus. And the one that has a difference of 2 angles gets the plus. And then those cancel. And I'm just mentioning that because in the event that you made a mistake here and here, it actually worked out for you anyway. But I want to make sure you're using the right SIGNs. So these two cancel, and then you have cos x, cos y, and another cos x, cos y. So you're finished with the problem. Number 79. I always like to throw this one in. Number 79 says, true or false, cos u plus minus v equals cos u plus minus v. That is a false. That's kind of the whole point of section 5.4. And don't feel bad if you got it wrong, because I usually have like a third of the class gets this one wrong when we do it. Even though we've been doing this for a couple days, this is not intuitive. So as badly as you want cosine u plus v to be cosine u plus v, it doesn't work that way. We know the formula is cos, cos minus plus sine, sine. So don't feel bad if you got that one wrong. Every year that happens. Here's number 87 from page 397. This is a solve example. So I'm not looking for the two sides to match. I'm looking to get an x equals at the end. So I've expanded here. Sine, the SIGNs match. So if there's a plus here, there's a plus from the formula. The minus gives a minus here. And then there's a minus in between. So when I expand this into 2 terms, I need to remember to distribute the negative. A lot of you may skip to here, and that's totally fine with me. Because this is a lot of writing just to show that I'm going to distribute the negative. I actually normally wouldn't show that step, but I showed it my answer key for you so that you could see why you get a minus here and a plus here. And then I personally like to cancel and combine terms before evaluating. But the sine of pi over 2 is 1. That's pretty nice. So it probably would have been okay if I had evaluated first. And cosine of pi over 2, by the way, is 0. So this would have canceled anyway, even if you didn't realize the terms were opposite. And once we isolate the trig function cosine, we can find the reference angle and quadrant or use the unit circle. And these are the 2 answers we get. We were solving in 0 to 2 pi, so that's why we just end with those. If I asked you to find all solutions, you could put a plus 2 pi n on each of those and just state that n would have to be an integer. And that was the end of the actual assignment. And then you go and watch your Edpuzzle. And if you want to come back and check on this challenge level problem, you can at the end. And it really is a challenge level problem. So let's go through that now. Okay. So this is page 382, number 67. I went ahead and actually already did the first step because it actually begins with cos x minus y times cos x plus y. And it's supposed to come out to cosine squared x minus sine squared y. Okay, so I expanded using the cosine angle difference formula. I expanded using the cosine angle sum formula. And then you actually have to FOIL this. So when you go to FOIL, you have cos x cos y times cos x cos y. That makes cos squared x cos squared y. And then your outers will be minus, it's positive times a negative, and it's cos x cos y sine x sine y. You can't make any of those squared because there's no exact repeats. It's either cos x and cos y. You can't make that cos squared because this has an angle x and this has an angle y. The inners give you plus sine x sine y cos x cos y. And last times last is a positive times a negative. And here you actually have sine x. That's why you're allowed to write it squared. And sine y times sine y. These two terms cancel. This all is one term, these four factors, and this term has the same four factors. One has a plus, one has a minus. I know they're not in the same order, so if that bothers you, you could rewrite this one as cos x times cos y times sine x times sine y before you cross them out, but they definitely cancel. And then we get to here, and this is often where students get stuck, totally understandably. And here's the key to how I think of it. This is what we're trying to get, right? So look at what we have and look at what we want. We have cos squared x. I'm happy to see that because that's in the answer. We don't have cos squared y. I don't want that in my answer. Sine squared x I don't want either, but sine squared y I'm very happy to see. So the things you're happy to see you want to keep, the things you're unhappy to see you want to try to change. So cos squared y we don't want. Is there some way that we can get that to be like cos squared x or sine squared y? Yes, and that's with Pythagorean identities. So if we, if we have cos squared y and we don't want it, by this Pythagorean identity, we can replace with 1 minus sine squared y. Don't forget the parentheses because you're going to have to distribute. And then the sine squared x we didn't want, right? Because it wasn't in the answer. So we can replace that using a Pythagorean identity with 1 minus cosine squared x. And I'm happy to see the cosine squared x because that's in the answer. So I know we're not finished yet, but at least we have the kind of terms we want to see. So distribute the cosine here. Distribute the sine here. And be careful with this part. So it's minus 1 times sine squared y. And then you have minus a negative makes plus. And then the product of these two. So this is cos squared x times sine squared y. So you have to be careful, especially with those SIGNs. And then what happens is you have a minus cos squared x sine squared y. That term cancels with the positive cosine squared x minus sine squared y. And you're actually finished. You have cos squared x minus sine squared y, and you're all set. So if you got to here, you really did great. And again, the key to the thinking, in my opinion, is look at what you have, see what you want to keep, see what you want to change, and then you have to be brave and try something to change it. And anytime you see a square, you want to think of Pythagorean identities. So that might help you with that one. Thanks for watching.